Welcome! In this session, we will learn to estimate a cutoff threshold by minimizing a cost function. So we are here ready in Excel with the CSV file that we exported from R with our predictions and with the real data of the dependent variable. The first thing that we are going to do is to put this data into a tabular format, so into columns. So we are going to data, text to columns. We click on text to columns, then we click on fixed width, or sorry, delimited, because they are delimited by commas. We click on next and we tell Excel that they are delimited by commas, and we click on finish. So now we have our data in columns. We said that the first one is the ID, the second one is the real data, so the real dependent variable defaulter flag, and the second one is the prediction. It's a probability, the probability that we predicted with our neural network. So in this session, we will learn to establish a cutoff point. So what will be the probability that we will estimate that higher than that probability, we will predict that that client will get in default, and lower than that probability, the client will be classified as a non-defaulter client. So we need some cost to establish that. So I'm going to add some rows. For example, we need the cost of or the false positive cost. We also need the false negative cost. We will also establish the cutoff threshold and the total cost. So as we are practically doing an academic exercise, we will establish that the false positive cost will be of $4,200. What is this false positive cost? Imagine that you predicted that a client was going to be default, was going to get in default, and actually he didn't get into default. So for example, you will lose, as you are not going to give him the credit, you will lose that money. You will lose that money that you will have received as interest for the credit. And those are those $4,200. On the other case, imagine that you predicted that the client was not going to get in default, and actually he get in default. So you give him the money, but he cannot pay for the card, and then there are some costs associated to recover that card. For example, you have to pay a lawyer, probably you will lose some depreciation on the card, there are some costs to resell that used card. So we will establish that those false negative costs are of $3,500. And once that you have both costs, you can establish a cutoff threshold, and that we will set by beginning that it will be of 0.5 as a seed value. And with this, we will establish the total cost, and then we will try to minimize that total cost and establish the actual cutoff threshold. And now let's classify the data based on the prediction and based on our seed value of the cutoff threshold, this 0.5. So classification, we will use the function if. If the prediction, the probability is higher than the cutoff threshold, then we will classify it as a defaulter, and if not, we will classify it as a non-defaulter. We copy and paste this formula in all the column, and now let's establish the false positive. we're going to use the function if and the function n. So because we are going to test two logical propositions. So firstly, we are going to ask, the false positives are the case in which we predict that the client was going to get into default, but actually he didn't get into default. So if D7 is equal to 1, so we classify it as a defaulter, but actually he was not a defaulter. So in the real case he was not a defaulter, that's a false positive. Then we will get a 1, and if not, we will get a 0. We copy and paste this one, and now let's establish the false negative. So what are the cases that are false negative? Those are the cases in which I predict that the client was not going to get into defaults. So when I classify it as a 0, but actually he get into defaults. So in the real case it is a 1. In those cases I'm going to get a 1, and when the two condition or one of the two condition doesn't apply, then I will get a 0. So now I copy and paste this one. I only get in 0. No, there are some ones. So now I have to add the false positive and false negative. I have 1161 false positive and 379 false negative. So with this classification I can establish the total cost for a cutoff threshold of 0.5. So now I'm going to establish the total cost. That will be the numbers of false positive multiplied by the cost of false positive plus the numbers of false negative multiplied by the cost of false negative. And for this specific case, that will be $6,202,700. Now we have to establish the cutoff threshold by minimizing the total cost. So we will start playing with different values for the cutoff threshold. We will start with 0, 0.1, and we will add 0.2 until we get to 1. And then we will start changing the cutoff threshold. For example, in this case, $6.9 million. I'm going to paste as a value 0.1, the same, 0.2, we have some change here, 0.3, 6.8 millions, 0.4, 6.4 millions. Like this. I'm going to fill this, I'm going to pause the video and fill this for respect of your time. So I have completed the calculations, and now we have to look for the number that minimizes this total cost. As you can see, there is say 6.9 in 0, 6.9, 6.9, 6.8, 6.4, 6.2, 6.1, 6.4. So probably the threshold value is between 6.5 and 0.5 and 0.6. So we can look for it if you want, 0.51, and this will be equal to this plus 0.01. We will look for it. 0.5. Actually, we have already these values, and we will look for the values that are in the middle, that are between 0.5 and 0.6. So we'll start playing again. 5.1. 6.1, 6.19, and I will complete this table. And once that you have completed the table, you have to look for the value that minimizes the total cost. And if you can see here, we have a 6.2, 6.21, 6.18, 6.21, 18, 15, 17, 14, 19, 18, and probably the value that minimizes the total cost is 0.58. So you will establish 0.58 as the cutoff threshold given this probability, given this probability, these predictions, and given this false positive and false negative cost. And practically with this, I'm finishing this session. Thanks for watching.